Okay, so these are what we call harmonic functions, right? And you recognize them instantly when you see that you have something sine x and something cos x, right? Sometimes there isn't even a number in front of them, okay? It's just going to be 1, isn't it? Sometimes, okay? But you know, okay, instantly you spot it. It'll be something sine x, something cos x, or the other way around. It'll be something cos x, something sine x. There won't be anything squared, right? It won't be sine squared x, nothing like that. It'll just be singular sine, singular cos. Okay, and we've got to express it in this form, r sine x plus alpha. So what I do is, right, I write 8 sine x plus 15 cos x, and they want it in that form. So I say, look, r sine x plus alpha. And what we need to appreciate here, we've got a compound angle, right? So two angles put together. And you simply open up your formula booklet, right, to page 4, okay? And just get this in front here. And you look at the trig identities, which is about halfway down the page. And we're looking at the sine one here, okay? So you've got your sine A plus or minus B. So in this case, right, your A would be what x is going to become, right? And your B is what alpha is going to be in this case here, right? So we've got an r in front, so don't worry about that, right? Just keep the r there. That's just multiplying. R is just multiplying by, so we keep the r there. And I'm going to do a square bracket because r has got to multiply it. So we'll just put the r there and we'll have a square bracket. Now sine x plus alpha. So if we follow the format here, as I said, a becomes x, okay, and b becomes alpha, quite simply, right? And we've got a plus here, so we've got to choose the top one, right? The top one here, which means we choose the top one in here as well, if that makes sense. It's got to correspond. So top one here, top one there. So if we follow the order then, we've got sine A, cos B. So sine A, now remember A is becoming x, so it'll be sine x. And cos B, and remember B becomes alpha, so that'll be cos alpha. And then, as I said earlier, because this is a plus in the x plus alpha, you choose what, and it's on the top, you choose what's on the top here, which is also a plus. And then when we've got cos A, so that'll be cos x. And then sine B, so that'll be sine alpha. Okay, close bracket. Now what I like to do next, right, I like to swap these around, okay, swap these around as well before I multiply through by r. Okay, so I'm going to just swap them around like that. Okay, there's nothing wrong with what I'm doing. It doesn't matter which order you multiply in. So swap these around, and then I'll multiply through by r. So I have r cos alpha sine x plus r sine alpha cos x. Okay, and then if I go look at what I've got on this side, which was what I had up there, notice now, comparing both sides, right? This is 8 sine x, but this side is r cos alpha sine x. And then I got 15 cos x, and this is r sine alpha cos x. So notice here we end in the sine x, end in the cos x, end in the sine x, end in the cos x. So what's in front of the sine x here, it's got to be the same as what's in front of the sine x here. Okay, they've got to correspond, they've got to equal. So, yeah, if that makes sense. So both sides are equal. So you've got a sine x here, so what's in front of it's got to equal what's in front of the sine x here. So we can say, look, r cos alpha is equal to 8, right? And then cos x here, what's in front of the cos x here is 15. It's got to equal what's in front of the cos x here, which is r sine alpha. So r sine alpha has got to equal 15. So we've got two equations, 1 and 2. Okay. Now we essentially, to get this part A answered, okay, we need to work out what r and alpha are, right? So that's the idea here. So r's got to be greater than 0, alpha's got to be between 0 and 90. So what I do is, first of all, I work out what alpha is. That's really easy. So I'm going to do 2 divided by 1. Okay. And if I do 2 divided by 1, you'll notice I've got r sine alpha here, divide by 1, which is r cos alpha. On the other side then of equals, I have 15 divided by 8. Now what you'll notice then is, of course, the r's will cancel. And you know sine alpha over cos alpha is just tan alpha. 15 over 8. So that implies then alpha will be tan to the minus 1, take the tan over, or 15 over 8, so you can get your alpha. Now, it's got to be in degree mode, because it says there, yeah, between 0 and 90. So, if I type that in, I get out 61.9 degrees. Okay, 1 decimal place is fine there. So I've got alpha. Now it's tempting to sub it in here, isn't it? It's tempting to sub it in. The trouble is, if you do sub it in, you might not get an accurate value for R, right? Because this is just an approximation, isn't it? It's only 1 decimal place. Calculator sometimes doesn't like it when you sub the answer in. So a good way of finding R is actually to use Pythagoras. And if you use Pythagoras, if you square, okay, these and add them, okay, something interesting happens. So if I square this, I'll have R squared cos squared alpha. And if I square this, I'll have R squared sine squared alpha. Okay, so square that, and add them, just like Pythagoras, isn't it? Square it, and add them. So I've got that there. But I've got to do the same on the other side, haven't I? Square that, and add them. Now what's good here is you've got a R squared as a common factor. So if I take that out, you'll notice then, of course, that is equal to 1. Okay, because cos squared plus sine squared is equal to 1. And you just work out that then 8 squared plus 15 squared is 289. Okay, so then R squared is 289. So then R, you just got to square root it, and you get 17 out. Okay, so therefore, 8 sine x plus 15 cos x is equal to R, yeah, which is 17, sine x plus alpha, which I've got to be 61.9. So we've expressed it in the form R sine x plus alpha.